Hello and welcome to Building a Data Center, a non-definitive guide. This is episode 1, Planning and Theory Crafting. Theory crafting is just my own personal way of saying brainstorming. So the purpose of this series is I am currently building a data center. Uh, I'm going to be doing a lot of things at data center, hosting for the clients, hosting for myself, hosting for uh, projects that I'm involved in. And so because of that, somebody had made the suggestion that maybe I should write down like a how-to or anything else, just because it would be kind of cool to learn how I build things. For some reason, they wanted my opinion. I don't know why. And then I was like, well, let me ask how many people might want this, and turns out a good number of people actually wanted to do this, or at least sit through hours of listening to my horrible voice droning on about data. So here we are making this video, and it's going to be a series. I don't know how long it's going to be. I have no clue on that. This is going to be a continuing thing. Currently, I am building a data center, like I said. So one of the things that you have to do is you have to plan, and it doesn't matter if you have a home network with 5 machines or you have this ginormous thing that you're building. Planning is still something that you should really try to scope out as much as you can from the very beginning. Um, for me, for instance, I'm going to have clients. I'm going to have lots of different requirements of this thing, and keeping it all straight in your head sounds wonderful in the beginning. Even my home network at first seemed like, you know, 3 machines. Oh yeah, I could totally handle that. And then all of a sudden it's 5, and then it's 7, and then you're at 13, and you're like, okay, I need to start thinking things. And these are all not virtual. These are like virtual machines, also not physical. Just wanted everyone to understand that I'm not the reason for causing most of the blackouts in the area. Um, so that said, let's start talking about for instance, naming conventions. When you build a computer, you do things like say, oh, this is Phil's computer, or this is um, Little Putnin for my daughter, or whatever, and that's cute and wonderful. And I mean, even even my current machine, is ptarrant-mate because I run the mate desktop. Um, and that's fine. But when you start getting into like data centers and building things, you need to kind of help think about the way that things move and work. And you realize quickly that your brain, like for me, I have the memory of a hamster. I can't remember anything. I go on these like wild tangents and um, build a lot of great stuff, and I'm like, yeah, I can totally keep track of that in my brain. And then after about 5 minutes, I'm like, what color is it? What day is it? I don't know. Um, so because of that, I recommend create a spreadsheet. Doesn't have to be anything crazy. Doesn't have to look pretty. Just something to help keep track of what's going on. Who's doing what. Um, Server name conventions is something that a lot of geeks talk about. There's actually a couple like XKCDs on that, I think. Naming conventions just means like how are you going to name your servers? And a lot of people do things like I have a buddy of mine who does everything Star Wars, right? He has Luke, Leia, Han, Jabba. That's the file server. He started with that, and then he was like, okay, cool. Well, I'm building a new network with new machines, so I can't use the old names. So I'll use all of the planets in Star Wars. And so he named his network, the domain. It's redacted Galaxy. I'm not going to say the actual domain name, but it's something Galaxy, right? And so he's got like Dagobah and Hoth and Tatooine and all these different servers that are named after that, and that's cute. I mean, there's nothing wrong with that. But for me, I'm at a point now where I'm past the funny names, and it's easier for me to keep track of things if I actually know what they are. So all my naming conventions I do like now, for instance, like if it's an application server, What is an application server? Well, an application server could be like a Minecraft server, right? So you can have, and maybe you want to name everything like, MC server. I like application because it could be used for lots of things. And also, if an attacker is watching traffic and they see app 01 go through, they don't know what that target would be. They don't know what they're looking at per se. DNS and FTP, yeah, they're going to figure that out pretty quick. But at the same time, an attacker is going to figure out if it's a DNS or an FTP server just by a quick scan of open ports. So, unless you do non-standard ports, which adds a layer of complexity, yes, but if they do an active port scan, they're going to see the banners that get sent back upon connection to those services. So even if you run a file server or an FTP server on port 7005, the minute they hit that port, they're going to see the banner of VS FTP, and they're going to be like, "Oh, I can totally own this." Um, Monitoring servers are things that might monitor your network, and I'll be setting those up, and I'll be showing you how I do that. I have several different ways that I monitor networks. Um, NAS, which is network attached storage. There's SANs and NAS, and it's complicated. But basically, network attached storage devices are basically file servers, proxy servers. Maybe you have a VM host, right? Maybe you have a web server. Maybe you have VPN. Maybe you have a firewall, and then this JMP. And a lot of people are like, well, what's that? Well, I'll get into that in a second because I don't want to blur lines. But all of this, right, you can name however you want. These are the things that I'm going to be using moving forward. This is just the way that my take on it. Obviously, you can change it, throw it out the window, whatever. Um, so when we also talk about planning and stuff, we need to talk about um, how we might split our traffic. Now, in the old days, people would run like 2 or 3 different network cards to manage our traffic and split and segregate things, and this is not feasible today. And we have these wonderful things called VLANs. So virtual LANs, VLANs, are basically a way for you to segregate traffic and it still be on the same switch, still be on the same network, even across the same wire, but everything's encapsulated so that it's all nice and pretty. Think of it like if traffic was moving through the network, kind of like water going through a hose. Okay. Now, with VLANs, you would be basically be installed like putting straws in that hose and then running colored water through those straws. So currently, let's say all your traffic is from all these different hosts, and let's say it's red, blue, and green, and that's the colors we'll call it of the network. And I'm trying to be very abstract here. But as this data is flowing through the pipe, they start merging together into this. Everything turns into basically the color purple going through the network. But if you have VLANs, you can segregate your traffic. So instead of it being one giant water hose, think of putting in straws, one for each type of traffic. And that way, inside that straw, the traffic can be seen, yes, but outside of the straw, you can't see it. And it keeps everything kind of separated. That's probably the best way I could think to describe it. Do some research on VLANs. It's completely worth it. And there are cheap options for you to be able to do VLANs without having to spend a ton of money on switches. So let's talk about why we want to segregate traffic. So for instance, so this is the cloud, right? And then we got our firewall. And maybe off that firewall, maybe we have some traffic that wants to go to our DMZ, demilitarized zone. Basically, it means that things that are hosting servers on the internet. So it's not 100% locked down, right? Because the internet can hit these things. Now, granted, the internet can't just come across and touch it. It has to go through your firewall, and then it goes to your DMZ. Um, and that's kind of the term that was created. Other things that we want to segregate out are like the Internet of Things, your smart TV, your phone, uh, anything nowadays that's smart, even light bulbs for God's sakes. They are a security nightmare because people build these things very fast and loose to get in the market quick, and there's really very little security testing on them. A good example is a friend of mine, he wanted to get a range extender for his Wi-Fi. So he bought one that was, like $30. And he plugged it into his wall, and it dawned on him. He was like, now this guy's a security researcher. Just going to say that up front. This is not how the normal people think. Um, but, he's a pretty good security guy, and he's like, maybe I should maybe sweep this thing and kind of see what it's doing. So he did, and port 22 was wide open, and it actually had an SSH banner, and he's like, why is there SSH open on this fucking range extender? And he was like, I wonder, maybe I should call the manufacturer. So he called the manufacturer, and he's like, hey, port 22 is open, and they're like, oh yeah, that's normal. And he's like, but why? And they were like, well, that's how we manage the settings. When you open up the app on your phone, basically it connects to our Wi-Fi thing, and it can, that's how you configure it. He's like, well, how do I turn it off? And they're like, well, you can't. And he's like, so let me get this straight. You have an SSH server built into this plug that anyone can connect to. And they're like, oh, don't worry. It's got a key. It has to have an SSH key. And he's like, oh, okay. All right. So he's like, well, thank you for your time. He hangs up, and he downloads the app to his computer, blows open the APK, and he finds the security key for the SSH right there. He's like, yep, this is going back to Amazon because anyone can download that app, get that key, connect to the device, and at that point they're on your network. They could be in a car sitting on the side of the road. Now, yes, you could sit there and say, man, you're like one of those tinfoil hat guys. Yeah, I kind of am. So's he. We also work in security. We do this stuff every day. We got to think about things in a weird way. And you could say, that doesn't happen to me. That's true. It might not happen to you. But let's think about some of the other weird things that happens. Like, for instance, like Ring, right? People are able to hack into the door cameras, right? We've just found out that um, the Nest thermostats have a built-in microphone that Google never told anyone about. They're like, oh, it's going to be a feature for later. Well, you kind of need to let me know if something's got a microphone. Um, anyway, I digress. I'm sorry, I'm going on a tangent. So anyway, so that's one of the reasons why you would want this as far away as possible from everything else. Just keep the traffic separate. So your smart TV can get hacked, and just weird things happen. Anyway, so VLAN 1 is a managed VLAN, and I say it's managed because typically all the switches and stuff kind of need to have a VLAN of their own, right? All the devices that control the network, it'd be nice to have them all on their own little thing. And so I kind of put it there, and then your trusted network is over here, and it's got all your trusted users and devices and stuff. And here's you, Mr. Administrator, right? You're the guy. And a lot of times you have your machine, and a lot of times people will have it hooked in to their trusted network and also in their VLAN, on the managed side. It's not terrible. I'll let that go basically for ease of use, right? Because you need to be able to get to this network, but you also need to manage occasionally. So what I do, this is just me, and don't forget, I've got a lot of things that I do. So I have a laptop that is 100% dedicated just to managing stuff. So this way, this is on its own VLAN along with the switch and everything else, and this is the only point of access. And then my computer is over here on the trusted side, away from this and away from everything else, so that everything's nice and segregated. And this way, I don't have to worry about if my machine gets compromised. Now they have a way to access all my switches. Um, Chances of that are pretty slim. And for the purposes of this tutorial and all of the videos I do, I'm going to break my own rule for a few. My switch is pretty easy to manage, so I can go in and I can give myself access to multiple VLANs at the same time. And so, for the purposes of this video, I will be doing this. But understand that if I'm not doing the video, I have a dedicated laptop for this stuff. Because, I mean, you can get a used laptop for $100, throw Linux on it, and it's pretty good. Anyway, so we're done with that. So let's talk about that stuff. Let's also talk about some security stuff. So VLANs, by the way, let's go back to that. Sorry. So we have our DMZ, right? And this is how you set things up. You basically, what is that word? That is not a proper word. So maybe, for instance, you have a DMZ, you have your trusted network, your Internet of Things, a guest network. So when people come by your house, they can go on the guest network. They don't need access to your file shares. And then anything that's configuration requirement, and things of that nature. And that could be things like, and this is, again, it's a data center. I'm going to be automating things. So I have like Puppet and Ansible and all these different ways to create a machine or do package management and stuff, software management that most people probably wouldn't have, but it's good to have. And also, you probably want to start keeping track of your IPs and what VLAN they're on. So, and they can't, you really don't want them to have the same IP space. Technically they could, but it's probably better that they don't. So maybe you do things like this. So you have that VLAN and then VLAN 20, and you do 10.0.20.1, right? And this is kind of like the industry standard on these things. This is what most people do. And keep track of these things in a spreadsheet or something. Lock it down a little bit so that no one else has access to it. Because once they have this, they have the keys to the kingdom as far as they know what machine is where. And yes, they can get online and they can, do scans, but once they get into one VLAN, they can't see the others. So it's just a good idea for you to keep things secure and whatnot. So now we're at the point where we talk about what are our needs for this data center that we're building, right? We need to be able to manage multiple virtual machines. We need to have a firewall. We need to maybe we want to control DNS. Maybe we want to control internal and external DNS. Maybe we want to do some real security things that are truly security oriented, because the way I'm building this data center is security first. I think about security very first thing out the gate, because implementing security after things are built is 1,000 times harder than if you just planned it from the get-go. This is why we take this big step. And planning and theory crafting, by the way, I spend a week on it. I build it out in a day, right? I spend a day, I think about it, and then I don't touch it for a day. I let it kind of just stew in my brain, and I think about things. And then I come back to it an hour, 1 hour, 2 days later, and I look it over and I go, does this still make sense? Because it may have made sense at the time, and then you look back and you're like, man, that doesn't make sense anymore. Or you start running into little weird issues and you start thinking to yourself, but what if I needed this, right? And so ask yourself these questions. Like, what happens if a client comes along and says, hey, I want to buy a second server from you, and I need them to communicate? Well, is that client currently on a VLAN? No, they're not. Okay. Or they are on a VLAN, but they're in a VLAN with everyone else, right? Um, Sorry, I'm also having to do other things at the moment. Um, so ask yourself these questions. Start thinking about things. If the client's not already on their own VLAN, maybe they're on a shared VLAN with everyone else. That's probably not a good idea. Put all your clients on their own VLANs. That way, if their machine gets compromised, it doesn't mess with anyone else's, right? Just little things you gotta start thinking about. And then if he comes along and he says, hey, I want to buy a second server or a fifth server from you, and I want all of them to communicate, okay, fine. They're already on the same VLAN. That's no big deal. And guess what? Your IP address doesn't have to change. That's another thing you got to worry about. So these are things you got to think about, and just kind of like throw little spitballs at this plan for at least a week. And after a week, if you're still satisfied with it, you can start implementing it. And one of the things that I need to make clear is that when you start implementing these designs, you if you run into a snag or something weird happens, don't get rushed and say, okay, I'll just work around that and break everything you planned. It's not worth it. Take a moment, sit back, think about it, and make sure that it's still going to work in the model that you've set forth for yourself. Anyway, so things we're going to be needing and doing. Again, we're going to need a virtual machine platform. There are many out there. There's Hyper-V, and everyone pokes fun at Hyper-V, but I'll tell you something. I ran a Hyper-V network for 5 years, and I never had a single issue out of that thing. It was clustered. It was able to do failover management. It was able to do all kinds of wonderful things. And yeah, it's a Microsoft product, but it's not bad. VMware, it's great. I just can't afford it. Hyper-V, I'm not going to run it in this environment because I really don't have any Windows machines in my environment at the moment. And I don't think I ever will. Not server-wise. Maybe I'll have a server, but I don't want to have my platform running on that. Mainly it's the cost. I just can't afford it. Datacenter edition of 2019 is very expensive. Now that they've gone to a core model, it's even worse. We're also going to need a firewall. Some people would make this a physical box, and that's fine. Nothing wrong with that. I'm going to use a virtual machine because I guess I'm asking for trouble. But I just am. My DNS structure is going to be a little different. I'm going to have one or two DNS servers, and I'll explain why later. So let's start with what am I going to use for my virtual environment, for my Hyper-V. I'm going to be using Proxmox. Many reasons why. It's got an API. I'm a programmer, so it's really nice for me to be able to create a VM programmatically. That's pretty cool. Now, you can do the same thing with VirtualBox. VirtualBox actually has a command line structure where you can create scripts that will automatically do certain things for you. And it's fine. There's lots of other products out there as well. There's ESXi, there's all kinds of different ones. There's Zen Server from Citrix. There's all kinds of them. But I'm going to be using Proxmox because that's what I'm going to do. So this particular box is going to be a standalone box. Later on in the data center, we're going to have other machines that are clustered. But I'm not going to join this machine to that cluster because this is designed to be a standalone machine, no shared resources really. And you see I've got 24 cores and 64 gigs of RAM. So it's not a super powerful box, but it's got a little heft to it. network-wise, this is where things get a little fun. So from here to here, I have 4 network cards in this device. Hold on just one second. Sorry, I had to drink. So 4 network cards in this device, and when Proxmox installs, it creates a virtual bridge for you. Think of this bridge as a virtual switch inside your VM, and Proxmox controls the data coming from your real card down to the VMs. And everything goes through this little bridge. A bridge in networking is a device that connects 2 network segments, 2 networks together. I modified mine a little bit because I have 4 network interfaces, and I want some type of failoverness, and I want some redundancy. When you're dealing with data center stuff, you need to think about redundancy and failovers. What happens if the network card goes out? What happens if I unplug the wrong cable? What happens if my switch dies? Right? So these are things you got to worry about when you're running larger machines. So I created a bond. You can do this very easily. Just click, create bond. There you go. And my bond has 2 slaves. Okay, network card 1 and 2. They auto start, and I gave it a comment. Always give your network devices a comment if you can. Life is much better for you if you do. Then that bond is actually a slave to this bridge. So this bridge uses this bond, which then connects to here. So to map that out a little bit, I'll just make a new one real quick. Nope, go away. So we have network 1, 2, 3, and 4. So we have 4 network cards. Okay. These guys go here and here. Okay. So this is my bond, and this is my bridge. That is a horrible decision. Let's use another shape. So my bridge connects these guys. So it's like that, okay? And these 2 over here are completely separate from everything, and we'll show why in a moment. So this one here, I did make a new bridge for it. Okay, 3 and 4. 4 is the external fiber, and 3 will be my failover fiber. And to give you an idea of that, there's reasons for this. So we have our internet cloud, right? And we have another internet cloud. And let's say this is our trusted devices. So our LAN side will be talking to over here. And again, we have these bridges that we've created, right? And so this number 3 goes here, and number 4 goes there. So number 4 goes to one service provider, and 3 goes to another service provider. So I have one ISP here, and I have another ISP here. So if one were to die, I've still got this guy going, okay? So my failover connection and my external fiber. That said, it could get more complicated, but we're trying to make things a little easier. So what are we going to use for a firewall? Well, I prefer OpenSense. It's based on BSD, which is super secure from the firewall perspective. It's been around for a long time. It started as a fork of pfSense and MonoWall way back in 2015. It's currently 2019. It's been around for 5 years. And honestly, I like it more than pfSense now. pfSense, rightfully so, has removed a lot of packages that are stale and not being updated anymore. And pfSense makes a really good case for that. That's not a problem. People seem to be a little more active in OpenSense nowadays. I prefer this over the other. I'm not going to get into a whole bunch of flame warring, but these are the things that our firewall does for us, right? We can do caching, proxy, traffic shaping, intrusion detection, which is huge. OpenVPN client, which is really great because I'm going to have people dialing into this thing all the time. And it has OpenSSL. It has all kinds of wonderful things built into it. DNS server, DNS forwarding, just tons of things you can do. VLANs, which are things we need. Um, it's just amazing. Okay, you can even do captive portals, two-factor off. I mean, just all kinds of fun stuff. So you can download this for free. Click download, select your architecture. Almost everyone today is going to be on 64-bit. And then I'm using an ISO because I'm going to be mounting it inside my virtual host. And select your download mirror and click download. There you go. Once you do that, you will go to your storage and you will go to upload in Proxmox. It'll ask you for a file, ask you what those two are. Of course, in this case, it's a ISO. Just create your file, click upload. It'll start uploading here, and now it's available to your Proxmox, in this case, your single machine cluster. Um, Interesting. Oh, I know what that is. It's my daughter's phone. Someone's trying to call her, and she's at school. Anyway, it's probably a spam number, honestly. So this is a good break point for the end of this video. Um, we will, in the next video, talk about how to install OpenSense and how to do the DNS setups and all that jazz. And we'll start working toward the goal of having a full-on, ready-to-go system. Again, thanks for your patience in my horrible video. I'm going to try to actually edit this on my own now. I'm going to try to make it a little better, although honestly, I don't think I've paused at all for breaking, for like cutting up clips. But if anything, we'll work on that for the next one. Anyway, thank you for your time. Have a good day.